Hello and welcome to the next video in the series of maths about properties of shape. The main focus of this lesson is to do with right angles and different amounts of them. You should know that the number of degrees in a right angle is 90. Have a look at your protractor if you're not sure about that. So if you're asked to fill in the gaps here, the number of degrees in a right angle, the number of degrees in a straight line, and the number of right angles on a straight line. If you have a look at the protractor, let's just draw the straight line for 90 degrees. You can see it's straight up. I'll put the protractor back on top again. You can see that that is 90 degrees. So then on a straight line, we've got one right angle and another right angle. So 90 plus 90. And how many right angles was that in a straight line? It's 2. Here's a table for you to complete. Think about right angles as a fraction of a turn, as well as just a corner. That's part of the reason that this type of protractor here has the turning part. Okay. So what fraction of a turn is a right angle and how many degrees is it? What fraction of a turn is a straight line? How many degrees? What fraction of a turn is 3 right angles? And how many degrees is that? And with a full turn as well. So if you can pause the video and fill in those gaps. And here are your answers. So a right angle is a quarter of a turn. So I'll try and demonstrate that with the protractor. I start from 0 and I turn 90 degrees. That's 1/4 of if I turn the whole thing all the way around. For a straight line, if I were to carry on turning, I would have made half a turn. And that is 180 degrees. For 3 right angles together, I would need to carry on. So I've now done 3/4 of a whole turn. That's 270 degrees. And then for the full turn, right the way back to the beginning again, 360 degrees. These are really key amounts to remember. Have a think about a compass. So for north, south, east and west, which are the blue lines that I've drawn, you can see that there's a 90-degree angle, a right angle between each one. There we are, that's 90 degrees. And also here, and of course the same here and here. If I were talking about the angle between the main compass points and those ones that are in between, like northeast and northwest, then hopefully it will focus. You can see that it's a 45-degree angle because it's half of 90. But actually then, if I turn my protractor round, I can see that the angle between, for instance, northwest and northeast, those in-between points, that's 90 degrees. Something to think about. Between which compass points can you see a right angle? A half turn, a 3/4 turn, and 45 degrees. Obviously there are going to be lots of different answers you could choose there. Let's see if you can just jot down one for each one, or maybe 2. Can you work out how many degrees there are between north and south if you're turning clockwise? And also, how many degrees are there between south and east if you're turning anti-clockwise? And also between northeast and southwest if you're turning clockwise? 3 questions to think about. So if I was going between north and south, turning clockwise, that would be 180 degrees. And actually it would also be even if I was turning anti-clockwise, wouldn't it? Because it's a half turn, it's a straight line. between south and east turning anti-clockwise, that's more important. South to east anti-clockwise, that's a quarter turn, isn't it? That's just 90 degrees. If I were going the other way, if I was going clockwise, then it would be 270 degrees. And northeast to southwest clockwise, again, because they're on a straight line, it's going to be 180 degrees. And actually, it wouldn't matter which way you turned there. For the next question, it might be useful if you have a compass drawn for yourself to look at. So you could use this screen to help you. So here's a word problem for you. Perry and Sam are asked how many degrees there are between northwest and southwest. Perry says there are 90 degrees. Sam says there are 270 degrees. Who is right and why? So if you take a look at the compass that I've drawn, you can see that actually both of them are right. Perry would be right if he says the degrees between northwest and southwest are 90 degrees. He's correct, as long as you're measuring going anti-clockwise. And Sam is right also if you're measuring going clockwise, because that reflex angle there would be 270 degrees. Always, sometimes, or never. West to south equals 90 degrees. Northeast to southwest equals 180 degrees. East to southeast going clockwise is greater than 90 degrees. Have a think about those, look at the compass and decide whether it's always, sometimes or never, and can you explain why? So from west to south equals 90 degrees. Let's have a look. There's west, there's south. So actually if you're going anti-clockwise, yes, that would be a 90-degree turn. But you could also go clockwise when it wouldn't be, so that makes that a sometimes. Northeast to southwest, 180 degrees. There's northeast, there's southwest. It's always on a straight line. That's always going to be 180 degrees, doesn't matter which direction you go. And from east to southeast clockwise, that means you've got to be going this way. That's never going to be more than 90 degrees. It's 45 degrees. This is the last question for this video. And now we're thinking about a clock face. So you may want to actually get somewhere where you can look at an analogue clock face or perhaps draw one to refer to. If it takes 60 minutes for the minute hand to travel all the way around the clock, how many degrees does it travel in 7 minutes and 12 minutes? So remember that there are 360 degrees in a full turn. And how many minutes will have passed if it's moved 162 degrees? So you've got a 3-part question there. So I suggest you start off by getting a clock nearby or drawing one. So I've started off by drawing myself a very simple clock face, just so I've got some idea of what I'm doing, marking on roughly where 7 minutes would be and 12 minutes, and actually measuring with my protractor 162 degrees, and that way I'll know if I'm close when I get my answers. So we know that 360 degrees is a full turn and 60 minutes is a full turn on the clock. So if you divide 360 by 60, you'll get 6. So that's 6 degrees for every minute. So if we're going to go 7 minutes around the clock, we do 7 times 6, and that gives us 42 degrees. 12 minutes around the clock would be 12 times 6, which is 72 degrees. But then for the third one, for 162 degrees, we know the degrees already, so we need to do a division then. We need to do 162 divided by 6, which gives us 27 minutes. And having a look at my diagram, which was only an estimate, that looks about right, doesn't it? The 7 minutes looks as though it's about 42 degrees. It's about an eighth of a turn. The 12 minutes looks like it's about 72 degrees. It's not quite a right angle yet. And 27 minutes would be about there on the clock. So I'm happy with my answers. That's the end of this particular video. Look forward to welcoming you to the next one. Bye.